Hi guys, this is Homework 12 preview video for Discrete math class. So this week we will be going over some problems in chapter 7.1, which is the discrete probability. So 7.1 is sort of the intro or review of some of the statistical counting problems, and we will be going more in detail in discrete math-wise in section 7.3 when we get to the Bayes theorem, as well as the expected values and the variance. All right, so I think I assigned all of these 4 problems. So let's actually go ahead and do some of these problems. Let's start with number 4. Okay. So these are pretty simple and problems that your work would only contain maybe 1, if not 2 steps to get to the answer. So number 4 is, what is the probability that a randomly selected day of a leap year is in April? So we know that during the month of April, and in the leap year is going to be 30 days. So we have 30 out of 366 possible days, and that's it. Hopefully you guys will be able to reduce all of your answers. So this would be 5 over 61, and that is actually the solution for number 4. We do one more, so maybe we can go ahead and do 6 together. So 6 asks, what is the probability that a card selected at random from a deck of 52 cards is an ace or a heart? So I always like to count the bigger pull first, which is a card that has a heart on it. So out of 52 cards, we know we have 13 cards times 4 decks. So there's going to be 13 cards with heart, and plus we have the ace, which there are 4 of them, and we already counted one of them, which is part of this heart. We know that ace of heart is already counted in it, so there's going to be a remainder of 3 more cards, because this is an or statement to include both cases. All right, so we have this over the total number of cards is 52, so this is it, and this reduces down to 4 over 13, which is the answer for 6. So again, when you guys go ahead and finish number 5 and 7 for the homework, it should take, it's just a basic counting problems, should take less than 2 steps to get to the final answer. All right, so I think I assigned a bunch of problems, number 9, 10, 16, 17. Those are all pretty much in the same category of counting the number of cards, so I'm just going to go ahead and do a bunch of similar problems. So number 8, what is the probability that a 5-card poker hand contains the ace of hearts? So throughout the section, we're going to be using the C. C is a notation for combination, which you guys should have read about in the book. So something A, comma B, this is the same thing, the notation-wise, written as this, or in some books, it's written as this. If you're using a graphing calculator, then the calculator uses this form, but usually I like to use this because I think it's simpler to write. Okay. So for this problem, we are choosing some cards to meet our requirement. I think probably it's easier for me to choose the denominator, which should be containing the entire sets of the possibilities. So for the denominator, I'm going to be writing as out of 52 cards, I'll be choosing 5. So again, that's equivalent to C, 52, 5. And on the numerator, to satisfy this requirement, we will be doing 51, choose 4. I think more accurately we should have this 1, choose 1. So here's what it means. We must have an ace of hearts. So that should be the given. So out of our 1, 2, 3, 4, 5 slots, in one of these slots we have to have ace of hearts. So we have no choice out of that one choice, which is the ace of heart. We have to choose that. So that's why we have 1, choose 1. And for the if the ace of heart is chosen, maybe here, then for these remaining 4 spots, so we have a choice out of 51 cards now, because out of 52, one of them must be selected. So out of the pool of 51 cards, we need to pick any 4 of them. So this is where this part 51, choose 4 comes from. Alright, so if you do this, you guys can use the online calculator. This should come down to 5 over 52, which is about 0.096. So probability-wise, the probability of satisfying this condition is about 9.6%. All right, so let's do a couple more. 11 says, what is the probability that a 5-card poker hand contains 2 of diamonds and 3 of spades, the 6 of hearts, the 10 of clubs, and the king of hearts? So they're being very specific. Out of 5-card poker hand, 1, 2, 3, 4, 5. Let's see if they're 2 diamonds. So this is going to be 2 diamond, and this has to be 3 spades, 6 hearts, and 10 clubs, and king of hearts. All right, so I think all of them are being very specific, which means there's only one case that this is going to be satisfied. Right, so this is the case of 1, choose 1. There's only going to be one. There's only going to be one card that has 2 diamonds on it, and out of that one card, we have to choose that one card. Same thing here. 3 spades. It's out of all the 52 cards, there's only 1 3 spades, and we're going to have to choose that. Same thing for all the cases. So the numerator on our probability fraction is going to be 1. And of course, on the bottom we have the entire choice of out of 52, we are going to be choosing 5. So this is it. This is going to be our answer. All right, so let's take a look at 12. What's the probability that a 5-card poker hand contains exactly 1 ace? Okay. So I think the denominator is going to be pretty much the same here, because out of 52, we're choosing 5 cards. Okay. And now for the numerator, how many ace cards are there? There are going to be 4 aces. So we have, out of 4, we're exactly choosing only one of them. Could be ace of heart or ace of diamond. Whatever it is, we're choosing 1 out of the 4. After that, we're throwing out the remaining 3 aces. Okay, so we started out with 52. We have to subtract 4, because these will be all the aces, because out of 4, 1 will be chosen, and 3 would have been thrown out. So now we have 48 cards, and out of 48, we have to fill up the remaining spots. We have 5-card poker. 1 of them has been filled up by one of the 4 aces. Then the remaining choices we have is 4. So this, if you do the calculation for this would be the answer for 12. All right, so these are pretty popular questions. I don't really know the rules of poker, so every time I come across these problems, I have to go back. I just Google it or look it up on Wikipedia to look up these definitions. So for 15, what is the probability that 5-card poker hand contains 2 pairs? And I had to look up what 2 pairs is. And here is an example of how the 2 pairs should look like. All right, so let's do this one. So let's first choose 2 different values of the card that will be pairs. Okay, so first step is choosing the 2 different values of the cards that'll be pairs. So this would be out of 13, because there are 13 cards in one deck. That would be 2 of them. Okay, so that probably accounts for these 2. All right, the second step is for each of these values, we have to pick 2 suits from the 4 suits available. All right, so we have to do picking two of the suits. So we have 4 suits available, and we're going to choose 2, and we're going to do that one more time. Or choose 2. All right, then you have to pick 2 more cards. Then we have to choose the value of the other card. Okay, so that's going to be 11, choose 1, since we have chosen 2 from the 13 deck. And the from its suit, that's going to be 4, choose 1. All right, so this is our numerator, and on our denominator, this would be our usual 52, choose 5. These type of poker card problems are pretty popular at the intro level of counting problems in the probability section. So I'll put up a link where you guys can practice more of these kind of problems, as well as the Wikipedia page for all the terms for those of you who are not familiar with the poker rules.